Hello everyone. This video is about chapter 1 pure mathematics. In this video we are going to discuss about subsection 1.1 functions and graphs. So the points we are going to discuss are the definition of a function or a mapping, the examples of a function, and the definition of domain, codomain, and range of a function, and some counterexamples. Now let us look at the definition of a function or a mapping. A function from a set A to a set B is a rule that assigns for each element A in a unique element B in B. So this is the definition of a function or a mapping, and let us try to understand this definition. So to define a function, first of all, you must be having two sets A and B. And after having the two sets A and B, each and every element of the first set A should have one image B. And this B is called image of A, which is assigned to the element A. And this assignment should be done for each and every element of the first set A, and this image should be unique. Only one image should exist for every element of A. So if the condition is satisfied, then it is called a function, and in the notation we write f is from A to B. So this is the notation for a function, and if the element A is mapped to the element B, under this function f, we write f of A is equal to B. It tells that the element small a is mapped to the element small b of the set B, and this function f can be written as f is equal to set consisting of ordered pair AB. So these are the two notations. We can write f of A is equal to B, or f is equal to set containing the ordered pair AB. Let us see an example. Take the set A is equal to C, D, M, 3 elements, and the set B is equal to 1, 2, 3. And f is from A to B, so it is a mapping from A to B, defined by f is equal to set of all ordered pairs C2, D3, M1. So the meaning is the element C is mapped to the element 2, and the element D is mapped to the element 3, and the element M is mapped to the element 1. So we can write it as f of C is equal to 2. So the image of C under f is 2. F of D is equal to 3. So the image of D under this function f is 3. And f of M is equal to 1. So image of M under this function f is equal to 1. So first we verify this satisfies the conditions of a function or not. From the definition of the function, we should have every element of the first set has an element in the second set which is image, or which is assigned to the element of the first set. So C has an image, and which is only one image. C has only one image, 2. And D has only one image, 3. And M has only one image, 1. So all the elements of the first set has images. All the elements have images, and each element has only one image, that is unique image. So this f defined by set consisting of ordered pairs C2, D3, M1 is a function. After that we look at the definition of domain, codomain, and range. So when we have a function from A to B, the first set A is called the domain. Here the domain is set consisting of C, D, M, that is A is the domain. And the codomain, the second set, we call it as the codomain. Here the second set is B is equal to set containing 1, 2, 3. Next, the definition of range. Range is the set of all images. So we find the images of all these elements in the first set. So element C and its image is 2. F of C is equal to indicates the image of C is 2 under this function f, and image of D is 3 and image of M is 1. So if we write all the images f of C, f of D and f of M, f of C is 2, f of D is 3, f of M is 1. Therefore the set of all images is the range. Here we are getting the images as 2, 3, 1, and therefore in this example the codomain and the range both are the same, because in the sets the order of the elements is not important. So the set 2, 3, 1 is same as set 1, 2, 3. Therefore codomain and the range are the same in this example. So let us have this question: are codomain and range the same always? In the previous example we have the codomain and range both are the same, but is it true always that the codomain and range are the same? So let us see this example F, where the elements of the first set are mapped to the elements of the second set, with A has the image 2, that is f of A is 2, and B is mapped to the element B, that is f of B equal to 3, and C is mapped to the element 2, that is f of C equal to 2. Now first verify whether it satisfies the conditions of a function or not. For f to be a function, each element should have images in the second set. So here A, B, C, all the three elements of the first set have images. And the second condition is that every element, each element should have only one image or unique image. A has here only one image 2, and B has only one image 3, and C also has only one image 2. Here we can observe that 2, the element 2 of the second set, is image of both A and C. But both A and C have unique images. A has only one image 2 and C has only one image 2. Therefore, for this example, f is a function, and if we see the domain and codomain, the domain of this function is ABC, and the codomain is the second set. The second set is 1, 2, 3, set containing 1, 2, 3. And if you look at range, by definition range is the set of all images. So images we find A image is 2, B image is 3, and C image is again 2. In the sets we don't repeat the elements, so even though 2 is repeated we write only once. Therefore set of all images is 2, 3, set containing 2, 3, which is the range. So in this example the codomain and range are not the same. So from this what we conclude is codomain and range not necessarily be the same always. In some cases codomain and range are the same, but they are not necessarily be the same always. Let us take next example. A is the set containing ABC, B is the set containing 1, 2, 3. F is from A to B defined as A is mapped to 2, that is 2 is the image of A, B is mapped to 2, and C is mapped to 2. First let us see, does it satisfy the definition of a function. From the definition we have to check every element of the first set should have image in the second set. So here all the elements A, B, C have images. A has image 2, B has image 2, and C has image 2. And each element should have only one image, not more than one. So here A has only one image 2, and B has only one image 2, and C has only one image 2. Therefore, F qualifies to be a function. And for this function, let us see what is the domain. Domain is the first set. First set is set containing ABC. And the codomain is the second set. The second set is 1, 2, 3. And the range. And range is the set of all images. So we have to write images of the elements in the first set. So A image is 2, and B image is also 2, and C image is also 2. Therefore, the set of all images is only the set containing only 2, as we don't repeat the elements in sets. Here, the codomain and the range are not the same. And this function we can write in the set of ordered pairs notation. F is equal to set containing A2. So A is mapped to the element 2, or 2 is the image of A, we can say. And again B is mapped to 2, B2, and C is mapped to 2, C2. So F is equal to set of all ordered pairs A2, B2, and C2. So if we look at the notation for a function, if F is a function from A to B, and if xy belongs to F, that means the element x is mapped to the element y in the second set, then we can write f of x is equal to y. And we call y as the image of x under the function f. So both these notations are the same. Xy belongs to f is same as f of x is equal to y, which tells that y is the image of x under f. And if we look at this example, f is equal to set containing 1a, 2, 5, 3b, 6c. So in this, 1 has the image a, and 2 has the image 5, 3 has the image b, and 6 has image c. And we can write 1a belongs to f, or f of 1 is equal to a. Both are same. That means a is the image of 1 under this function f, and we can write f of 1 is equal to a. Similarly, 2, 5, the ordered pair 2, 5 belongs to f. That can be written as f of 2 is equal to 5, which tells that the image of 2 is 5, or 2 is mapped to the element 5. Similarly, 3b belongs to f is same as f of 3 is equal to b. 3 is mapped to b. And 6c belongs to f is same as f of 6 is equal to c. So the element 6 is mapped to c, or the image of 6 is c. So this is the notation we use. Let us look at the next example. A is the set containing A, B, C, D, and B is the set containing 1, 2, 3, and G is defined this way. A has the image 2, and B has the image 3, and C has the image 1. Now let us check whether G is a function or not. If we verify the conditions of a function, each element of the first set should have images in the second set. So here A, B, C, the three elements have images, but the element T has no image. Therefore, for this question, is G a function? We can say no. So why G is not a function? Because this D, element D, has no image. Since one of the elements in the first set has no images, this G is not a function. Let us go to the next example. Take the set A equal to A, B, C, D and B equal to 1, 2, 3. And G is defined this way. A is mapped to 2, B is mapped to 3, C is mapped to 1 and D is mapped to 3. So is G a function? Again we look at the definition. Each element of the first set should have images and those images should be unique. So here A has image 2 and A has only one image 2, unique image. And B has image 3 and B has only one image 3. B has no other images. And C has image 1 and C has only one image, unique image 1. And D has image 3 and D has only one image 3. So all the elements of the first set, the domain, have images and all these elements have only one images, that is unique images. Therefore G qualifies to be a function. For this one let us write what is the domain. First is the question, is G a function? Yes. Why G is a function? Because all elements have the unique images in the second set. Let us take another example where A is mapped to the element 2, A is mapped to the element 3, B is mapped to the element 3, C is mapped to the element 1. So is G a function here? Let us verify the definition of a function. All the elements of the first set have images and the second condition, each element should have only one image. That condition fails here because the element A has two images. A has the image 2 and the same element A has another image 3. So the element A has two images, not one image, two images. So the uniqueness of images fails here. Therefore, for this question, is G a function? No. And why G is not a function? Because the element A in the first set has two images, namely 2 and 3. A has two images, they are 2 and 3. And we can write G of A equal to 2, G of A is equal to 3. For the same element A, we have two images. Therefore, G fails to be a function. G is not a function here. Now we can write the functions as set of ordered pairs. A function from a set A to a set B is a set of ordered pairs in which no two first components have the same element. So when the function is given as a set of ordered pairs, to verify whether it is a function or not, we use this definition. The definition tells that no two ordered pairs have the first component same. That means no two first components have the same element. Let us check by taking an example. Here F is given as set of ordered pairs A2, B3, C1 and D5. So A has the image 2 or A is mapped to 2, B is mapped to 3, C is mapped to 1 and D is mapped to 5. So all the elements A, B, C, D have unique images. A has only one image, B has only one image 3, C has only one image 1 and D has only one image 5. Therefore, F qualifies to be a function. And here no two first components of the ordered pairs are same. Here A and B are the components, first components. They are not same. Similarly, A, C are not same, A, D are not same. So no two first components are same. Therefore, this qualifies to be a function. Let us look at the second definition of G. G equal to set containing ordered pairs A2, B3, A1, D5. Now here, does G qualify to be a function? No, G is not a function because the element A has the image 2 and the same element A has another image 1. That means the element A has two images which fails the condition of uniqueness of images. Each element of the domain should have only one image. Here A has two images, therefore G is not a function, and from this definition also no two first components should be same, but here the first components of this G are the same. The two ordered pairs A2 and A1 have the first component same A, therefore G cannot be a function. Let us go to another. F1 defined by set containing ordered pairs A2, B3, C1, B5. So is F1 a function? Again, no. The reason here is the element B has two images. B has the image 3 and B has the image 5. Therefore, this F1 cannot be a function. Again, look at this one. No two first components should be same. No two first components should be same. Here, the first components are same, which is contrary to this definition. So B is same here and here. Therefore, F1 cannot be a function. Let us see F2. F2 is defined by set containing A2, B3, C2, D3. Is F2 a function? Here, yes, because all the first components are different. No two first components of ordered pairs are same. If you observe, A, B, C, D are the first components of these ordered pairs and no two first components are same. Therefore, F2 qualifies to be a function. And F3 is defined by set containing ordered pairs A2, B3, D1, D5. Again, is F3 a function? No, as the element D has two images. D has the image 1 and D has the image 5. So the element D has two images, 1 and 5. Again, contrary to this definition, no two first components should be same for anything to be a function. Here, the first components of the two ordered pairs are the same, D and D again. Therefore, F3 is not a function. Now let us look at the definition of variables. The independent variable. The placeholder for the elements in the domain is called the independent variable. There are many values in the domain, but all the values are represented by one variable. We call it as independent variable. And dependent variable, the placeholder for the values of the range is known as the dependent variable. So let us try to understand the concept of this independent variable and the dependent variable. So this is a set, the first set, the domain, and this is the second set, the codomain, and there is a function f which maps the elements of the first set to the elements of the second set. There may be many elements in the first set, but all these elements are represented by one variable. Here we take x. So this variable, which is representative of all the values of the domain, is called the independent variable. So generally we take x as the independent variable which represents all the values of the domain. Same way, the range are the images. So the images are f of x, and we write f of x is equal to y, which are representative of the values of the range. So range contains all the images. All the images are represented by one single variable. Here we take y. So y is the single variable that represents all the values of the range or the images. Range is nothing but set of all images, and all these images are represented by one variable, single variable y, and y we call it as dependent variable. So again, let me repeat, x is the representative of values in the domain, and this x is called independent variable, and y is the representative of values in the range. Range means images set, and this representative of images is called the dependent variable. Here we take y as the dependent variable. Now let us take function as an equation. Here the range is given by this equation, f of x is equal to x minus 1. F of x is nothing but the image of the variable x, and x is the independent variable, or which denotes the values in the domain. Here the domain contains the elements -2, 0 and 2. So all these are represented by the independent variable. The independent variable is x, and the values of the dependent variable, that is range, and range is given by here f of x. F of x is nothing but image of x, and we have to find the images of these elements in the domain. So let us take first x is equal to -2. If we put x is equal to -2 here, f of -2 will be equal to 2 times -2, that is -4, -1. So it will be -5. F of -2 is -5. That means image of -2 under this function f defined this way is -5. Next, f of 0. The element 0 is mapped to. So let us put x is equal to 0 here. So 2 times 0 is 0. 0 minus 1 -1. So f of 0 is -1, which tells that 0 is mapped to the element -1. And next, the image of 2. So let us put x is equal to 2 here. So f of 2 will be equal to 3, because 2 2s are 4 and 4 minus 1 is 3. So the image of 2 will be is equal to 3. So this is how we are finding the images of the elements in the domain. So in the domain, the elements are -2, 0 and 2, and we found their images as -5, -1 and 3 if the range is given. Here the range is given as an equation. So the domain of this function is the set containing -2, 0 and 2, and the range is nothing but set of all images. So the images are -5, -1 and -3. So this is how we can find the images if the function is given as an equation. With this, we come to the end of this video. Thank you.